Hi, my name is Tianzhen. In this presentation, I'd like to share a recent work entitled Directed Tokens, a robust multimodality alignment approach to large language vision models. This study is a collaboration between the University of Arkansas, USA, Vietnam National University, Ho Chi Minh University of Science, Vietnam, and Carnegie Mellon University, USA. This study is supported by NSF. Large multimodal models, LMMs, trained with visual instruction tuning, excel at instruction following and visual reasoning. While most recent LMM research focuses on scaling data and models, this work examines their overlooked but critical pitfalls. In particular, LMMs are usually biased to language preferences since the LLM has been pre-trained on the access scale data. Meanwhile, due to the data complexity, the LMMs tend to overlook the information of visual inputs. For example, an LMM like Lava 1.5 can achieve similar results using only languages, while the important parts in the visual input are covered. Here's the table of the performance achieved by Lava in two scenarios, one with original images and the other with the partially covered ones. As being shown, the performance of the models is still maintained without the correct visual information. This problem indicates the multimodal alignment in current LMMs has not been well addressed, leading to prioritizing language preferences and overlooking the visual information. So, in this paper, we present a new directed token approach to improving the robust alignment between visual and textual modalities by solving shuffling problems. In particular, we propose two new learning tests of reconstructing the image and text order. Next, we propose a new directed token approach to capture visual and textual knowledge, and a new image-to-response guided laws to further improve the visual understanding. Through extensive experiments, a proposed approach has achieved state-of-the-art performance on academic task-oriented and instruction-following LMM benchmark. Image order reconstructing task involves randomly shuffling the image patches for a given image with a permutation function. The LMM must then reconstruct the original image order based on the provided textual description. The textual description is crucial as it serves as a vital reference knowledge. Since the current framework did not support this new reconstruction task, we propose using a learnable directed token and placing it at the end of the token sequence. Then, we can use the visual order projection layer to predict the correct permutation to reconstruct the original image. Since the directed token is placed after the instruction data, it can efficiently capture knowledge from both visual and textual features through the self-attention mechanism with autoregressive modeling. Next, we introduce a new reconstructing text order task. Formally, given an original image and a shuffled word order description, the goal of this task is to encourage the LMM to predict the original description matched with the visual information represented in the image. Although this task could be easily accomplished using the LLM part, visual information plays an important role in improving the visual understanding of the LMM in this learning paradigm. In this example, you don't want to wrongly reconstruct the text with a person wearing a blue shirt. In similar scenarios, having the image is important since it provides an additional reference that aids the LMM to accurately reorder the shuffled descriptions. Moreover, enhancing the visual knowledge in the response is also important, as it helps the model capture more visual features and consequently enhances the robustness of its answers. We propose a new image-to-response guided laws, which enforces attention learning based on the prior knowledge derived from the image and the response. Therefore, it enhances the impact of the visual features on the corresponding textual responses. Here are some running demos comparing the Lava 1.5 and our proposed approach using directed tokens. Thank you for watching.